Now we'll see one important aspect of function, that is call by value or call by reference. So if you're having idea about C++, in case of C++, we can call a function either by value or by reference. So we'll understand the meaning of value and reference from here. Suppose this is our function. We have written it, very simple function, adding two numbers, returning value. Now these are two variables in which we are storing some value, and we are calling this function through this variable. So say we are saying t is equal to add x comma y. So we already mentioned xy are known as an arguments, ab are known as an parameters. So question is that, see, value of x we are available over here in a. Now question is that, suppose if I make changes in a, like say if I say a is equal to 45, whether that change will reflect in x. Okay, whatever, if we making changes in parameter values, whether those changes will be get reflected in arguments. So that will be defined by how you are calling this function, by value or by reference. Okay, so in case of call by value, what happens, see, the function receives a copy of the argument object passed to it by the caller. Means a and b are just nothing but copies of x and y. A and b, which are parameters, are just nothing but copies of arguments x and y. So obviously if you make any changes in ab, that will not be reflecting x and y. See, once again, x and y are arguments, a and b are value. So in case of call by value, values of arguments get copied into parameters. So parameters are new variables. Memory of AB is different than memory of XY. So if you make any changes in AB, that will not obviously get reflected in XY. So that type of function call is known as a call by value. Second option what we are having is a call by reference. So in case of call by reference, the function receives reference to the argument objects passed to it by the caller. So in case of call by reference, XY and AB both are referring to same memory location. Means where x is pointing, a is pointing to same memory location. So obviously if you make changes by a, it will be reflected in x. Okay, so that is call by reference. So in case of call by reference, if you make any changes in parameters, that will obviously get reflected in arguments. And another words you can say parameters and arguments are same memory locations. In case of call by value, parameters and arguments are two different memory locations. So that is exact difference between call by value and call by reference. So now next question arises, what exactly Python follows? Whether it follows a call by value or whether it follows a call by reference. So in case of Python, you can say Python neither follows call by value nor follows the call by reference. Instead of that, Python utilizes one new system, a new mechanism known as a call by object reference. Okay, in case of Python follows a different kind of mechanism, different kind of system. Rather than going with call by value or call by reference, you can call it as a call by object reference. See, previously we said that Python is an object-oriented programming language. So according to object-oriented programming language, everything is an object. And in case of Python, you can say almost everything is an object. Means like integer, double, float, integer, float, string, list, tuple, whatever we have seen up till now, everything is just nothing but object. So in those objects, some objects are immutable one and some objects are mutable one. Like we have seen, string is immutable, integers are immutables, then you can say float values are immutable one, and like list, tuple, set, these are mutable objects. So immutable objects are passed to the function as a call by value. Okay, we'll see by one example. See, integer, we'll make one change here. Now we'll go with string value. Let's call one show name, and here we are printing name. We are creating one variable x, calling this function here. Okay, so I will print this x over here. That's working fine. That's okay. Now we are making change to this name variable. So here we are saying suppose some xyz. Okay. Now see what happens. So xyz, whatever change we made to this particular string is only applicable inside this show function. Value of x over here is not making any change. Okay, because this is a call by value type of function call, means this x is different variable, this x is representing this different memory, this name is representing different memory, because strings are immutable. See, we'll show it how it is immutable. Now we'll just make one small change. We are taking this as an integer variable now. Okay, so it's a straightforward code. 100 gets printed. Now see, if you remember, previously in one session we said that there is one function known as an id, which returns you id of every variable. Every variable is having one unique id associated with it. It's like a memory address of that respective variable. You don't say it exactly as a memory address, but every variable is having one unique id by which it is uniquely identified here. Okay, so if you try to print id of t here, and same way here we are printing id of x, see what happens. Id of both variables remains same. So right now you can say this x and t are same because IDs of both objects remain same. Okay, so then how it is called by value? Now check here. Now we are changing, see here, we'll keep as it is. Here we are changing value of t to 200. We're changing value of t to 200 and we'll do these two operations again here. Now understand it very carefully, how we can interpret this output. First your program starts here, it is printing id some 736 at the end. Then you go to show function. Now you are printing id, it is still remains same, so both are pointing to same memory. When you say print t, it is printing 100 value, so value of t is remains same like a x. Now you are changing value of t to 200, and now you can see immediately id of this object is changed. Once you modify value of this parameter, id of this parameter is changed. Means now it's a completely new variable. It is nowhere related to x. Id of this variable is different. Value of this variable is a different. Value of x remains 100. Id of x remains original one. Okay. So until and unless you are not trying to make any change in this parameter value, IDs or variables means values of parameter and arguments remain same. Once you make change to parameter, it immediately creates a new memory, it immediately creates a new id, and that will be now a completely new variable. It is nowhere related to your argument. So that type of function call is known as a call by value. It happens with all sorts of an immutable objects like int, float, string, tuple, boolean, complex. All these are just nothing but immutable objects. So now what is exactly call by reference? If you go with mutable object, means if you're trying to call functions by using mutable object, which are mutable object? List, set, dictionary, all these are mutable objects. Now if you try to call a function by using mutable objects, it will be a call by reference. So see example, say we'll make very small change over here. Now this is a list, this is a list here. We'll add this element, this list here. Call this append function. Okay, see that is the only change. Now x we represent as a list, and in show function we are adding one another element to this list here. Now see the output. What happens? First of all, see id initially is some 416 that we are printing here. Then we are calling show function. Id remains same, value also remains same, 100. Now you are adding one new element, mean to say you are changing this list now. But you can see this id still remains same. It means that you are having only one copy of list, which is represented by this parameter t also and this variable x also. Now you are adding one new number to this list. You are printing it here 100 and 200, and you print it here. Here you can see this change what we are making inside this function is reflecting over here also. So this is known as a call by reference. This is known as a call by reference. So finally you can summarize like this. In Python, we neither follow call by value, neither follow call by reference. Python is going in some different way. Whenever you pass immutable objects to function as a parameter, it work in call by value fashion. Whenever you pass mutable objects to a function as a parameter, it works like a call by reference. So in and all, we can call it as a separate mechanism like call by object reference or call by assignment.